All right, so this is the answers for 4 and 5 for the 3 variable equations. I'm going to look at number 4 and I'm going to say to myself, okay, there's a couple things that I see. One is, are they all lined up? And what I mean by that is all my x's lined up, all my y's lined up, all my z's lined up, all my constants lined up, my equal signs lined up. So yes, everything's lined up there. Second thing I notice is that my x is by itself, which means if I multiplied this first equation by something like -3, right, then the x's would cancel out, which is nice. So you could take a combination of the first and the second. And if I looked at the first equation and the third equation, again, if I multiply this by -2, now all of a sudden this would cancel with the 2 down here, right? So that's the first thing I'm noticing. If you wanted to, you could also have looked at the second equation and looked at the -z, and again, that would have been pretty easy to eliminate here as well. But let's just stick with what I think probably most of you guys noticed at first, and let's just try to eliminate the x's in these equations. So the first thing I'm going to do, I'm going to take these two equations. I'm going to write my first equation and my second equation, just to keep myself organized. And I'm going to multiply the first equation by -3. So I would get -3x plus 15y minus 9z equals, let's see. I'm sorry, it's a negative. So -117. All right, so now that I've multiplied by -3, I'm just going to kind of cross that out just because now I'm dealing with just these two, right? Because once I multiplied by -3, this is now my first equation just modified. So I eliminate the x's. I'm left with 23y minus 10z equals, I would get 16, carry the 1, so that would give me 3. So -136. And now what I have here is what is called my reduced equation, or reduced system. Okay, because what has happened? We have eliminated the z. Right, that's what we've done. We've eliminated the z. I'm sorry, not the z. We've eliminated the x. Okay, so I'm just going to pause. All right, so now I'm going to try and get rid of the x again. So I'm going to multiply, I'm sorry, not multiply. I'm going to take the first equation and let's take the third equation. All right, you just can't take the same combination. So I'm taking the first and the third. Let me pause so I can write this down. All right, I know the clicking is probably annoying, so I just wanted to kind of save your ears for a second. So now I'm saying to myself, I want to try and eliminate these x's. So what I would do is I would multiply the top equation by -2. If I do that, I would get -2x plus 10y minus 6z equals, what is it, 78? -78? Yeah. All right, so now that I've multiplied this top equation, I just like crossing it out just so I keep myself organized. Now I'm going to add these two together. The x's are going to cancel out. I'm left with 4y minus 11z equals -107. And this is my other reduced system. And the reason is because I have eliminated the x's. So now with these two reduced systems, you are essentially at the start of an elimination problem. All right, and then my second one was 4y minus 11z equals -107. Now, unfortunately, it's not super nice. None of them are like going to be that easy. So I just look at 10 and 11, and I'm just going to multiply the top one by 11 and the bottom one by -10. And the reason is because if I do this, I'm definitely going to need a calculator for this one. But if I do this, I'm going to get a negative I'm going to get a negative my calculator wasn't turning on. Okay, sorry. I would get a negative 110 here, and I would get a positive 110 here, which would eliminate the z's. So I get 11 times 23, which is 253. Again, like I said, we get minus 110z equals 136 times 11, which gives me 1496, and that's going to be a negative. Sorry, I forgot the negative sign. And the second equation, I'm going to get negative 40y. Oops, I forgot a y up here. Negative 40y plus 110z, and then 107 times 10 is going to give me a positive 1070. So now if I'm looking, if I add these two together, I'm going to eliminate the z's. So if I have 253 plus negative 40, that'll give me a 213y equals 1496. Would give me a negative 426. And now I'm just hoping that it's going to work out, and it will, because it'll give me a negative 2 for my y. So most of my work's done now. Now I have to just go back and put this into one of my reduced systems, because if you put it back into one of the original ones, you would still have a x and a z. So I'm going to put this into this equation right here. So I would get 4 times negative 2 minus 11z equals negative 107. So that gives me negative 8 minus 11z equals negative 107. So if I add 8 to both sides, I would get negative 11z equals negative 99. So my z is going to be a positive 9 if I divide by negative 11 on both sides. Okay. And now I will put both of those into one of my original equations. So I'll just pick the first one. Doesn't really matter. X minus 5, we know what y is, and we know what z is going to equal 39. My y, right, was negative 2, and my z was positive 9. So I would get x plus 10 plus 27 equals 39, which is x plus 37 equals 39. X is going to be 2. Okay, so my answer would be 2, negative 2, 9. All right, number 5, I'm going to again say to myself, what could I eliminate? Well, if I see this x and this negative 3, if I multiplied the first equation by 3, it would get rid of the x's. If I multiply the if I'm picking the first and the third, if I multiplied the top by negative 7, it would get rid of the x's. All right, so that's just what I'm thinking in my head. So I'm going to pick the first and the second, and I'm going to eliminate the x's here. Okay, I'm going to multiply this by 3. and I get 3x plus 3y plus 9z equals 36. So I would get, if I add them together, the x's go away. I'm left with 10y plus 7z equals 1. That's my first reduced system. Then I'm going to take the first equation and the third equation, and I'm going to multiply the first equation by -7. And I get 84 here. Yeah, I get 84. So if I add these two equations, get rid of the x's, I get negative 13y minus 26z equals negative 52. And that is my second reduced equation. So now what I'm going to do, I am going to solve this just like it was I would solve it just like I would solve a elimination equation with two systems and two variables. All right. Again, a little ugly here. So I'm just going to pick, let's multiply this by 13. Let's multiply this guy by 10, because then I could eliminate the y's, because what I'd be left with is 130y. 13 times 7, 91. Z equals 13. And then this equation, I would get negative 130. Negative 260z equals negative 52 times 10. Add them together, get rid of the y's. I get, let's see here. I get negative 169z equals negative 507. So now let's hope that this can be divisible by 169. Yes, it is, and it's a positive 3. Now that I know z, let's put it back into one of the equations. Let's put it into this one. So I get 10y plus 7 times 3 equals 1. So 10y plus 21 equals 1. 10y equals negative 20. Y equals negative 2. Now I just put it back into one of the original equations, which is all kind of messed up right now. But let's pick this first equation, because the first equation is actually pretty nice. So the first equation was x plus y plus 3z equals 12. So I'm going to put in, right, we still don't know x, but I know y is negative 2, and I know z is 3. So I get x, minus 2 plus 9 equals 12. X plus 7 equals 12. What plus 7 equals 12? X is going to be 5. So my answer would be 5, negative 2, 3, because I have my x, my y, and my z. That's my answer.